So welcome to Unit 3, guided practice for the remediation practice. It says define the following terms. Energy. Energy is the amount of work over time. Calorie is a dietary calorie is actually a kilocalorie. And a scientific calorie is actually um, it's one or 1,000 of the kilocalories. They both in a kilocalorie, 1 kilocalorie equals 4.184 kilojoules, and a calorie equals 4.184 joules. Law of conservation of energy, that energy cannot be created or destroyed, meaning the energy we have before is the energy we have afterwards. A conversion factor is a way that we can convert between two different units. Chemical potential energy is the energy that is stored in chemical bonds. Elastic potential energy would be the energy stored in a spring or in a rubber band. Radiant energy is the energy from the sun. Kinetic energy is the energy of movement. Heat is the energy of the particles that are moving. Gravitational potential energy is the energy of our position on Earth. So if we're really, really high, we have a high gravitational potential energy. Work. Work is a product of our force times distance. Power. Our power is going to be a product of our work over time. And our joules. Our joules is the measure of the amount of energy. Defining energy says convert between 750 calories into standard units of energy. And so when we're looking at this, it is capital C calorie. So therefore, that is 750,000 normal calories. And we know that 1 calorie is 4.184 joules of energy. And so what we will have is we will have our 750,000 times our 4.184, which will give us right around 3.1 million joules of energy. And that's million joules of energy. It says describe the energy conversion, explaining photosynthesis. So we have our radiant energy that is absorbed by the plants, uh, turning our carbon dioxide and oxygen into chemical potential energy of our sugar, which is then used to fuel the plant. C says a long distance runner requires bars, gels, or some other food source to finish a race. Why is this the case? Because they run out of energy because they are using up all of their calories to move their muscles and convert it from chemical potential energy into kinetic energy. So, looking at the difference between work and power, our work is our force times distance, and our power is our work over time. So, it says calculate the work when the force to move a 10 kilogram box 20 meters. So, it's force times distance, or sorry, work equals force times distance. And so our force is 50 times a distance of 20 meters, which would give us 100 for our answer. See, it says, how can you determine whether incandescent light bulbs have the greatest power? Well, power is measured in our watts. And so you just look and see if it's a 100-watt bulb. That means it has a greater power. Kinetic energy, it says, where will the object have the greatest kinetic energy? Well, kinetic energy is 1/2 the mass times the velocity squared. So if we're looking at this, it will have, if it's the same object, well, wherever it has the highest velocity will have the highest kinetic energy. B, it says calculate the kinetic energy when 1 kilogram ball moves 5 meters per second. So kinetic energy is 1/2 times our mass, which is 1, times our velocity squared. So 5 squared is 25. So we would have a kinetic energy of 12.5 joules of energy. It says calculate the kinetic energy when a 2 kilogram ball moves 10 meters per second. So, same equation, 1/2 the mass times velocity squared. Try that one out. When looking at gravitational potential energy, it says where will the project have the greatest, or the projectile have the greatest gravitational potential energy? Well, it's at its highest peak because gravitational potential energy is just our mass times gravity times height. So our height is going to be the biggest there. Greatest gravitational potential energy. It says calculate the gravitational potential energy when a 1 kilogram object is raised 5 meters above the Earth. So gravitational potential energy, GPE, equals 1 times our distance of 5, which is our height, times gravity. Instead of 9.8, let's just go ahead and call it 10 for math's sake. And so we go 1 times 5 times 10 would give us 50 joules of energy. The next one, it says calculate the gravitational potential energy when a 2 kilogram is raised 10 meters above the Earth. And you can go ahead and say that this is 10 meters per second squared. Go ahead and try that one out with the same equation. Next is heat. It says at what point has an object absorbed the most heat? Well, it would be where it had the greatest temperature, which is up there. B is the difference between heat and temperature. Temperature is the measure of the average kinetic energy. Heat is the amount of energy stored in that system. Describe how each method of transfer occurs in the kitchen. So we're looking at this as conduction, convection, and radiation. Conduction is actually touching something. So actually touching if you're cooking something in a pan, whatever is cooking, touching the pan. Convection is just the hot and cold flowing from bottom to top. You can think of boiling water there. And then radiation would just be the light. So some type of light coming in and heating it up. Conservation of energy. It says a ball originally has 200 joules of energy, equally split between kinetic, gravitational potential energy. The ball drops to the floor and has 0 joules of gravitational potential energy. How much kinetic energy does it have? Well, energy is conserved. So therefore, if it has 0 gravitational potential energy, that means all of it must be converted to kinetic energy, which would be 200 joules. B, it says what is the mechanical energy of the system below? Mechanical energy is just all the energies combined, so kinetic and potential. So it would just be our 25 plus our 10 plus this is looking like 4. Add all those together and that's your mechanical potential energy. It says a 5 kilogram rock is moving at 10 meters per second, 8 meters above the Earth. What is the mechanical energy of the system? Well, it's the kinetic energy plus the gravitational potential energy. So it's above the Earth. We have a 5 kilograms, so gravitational potential energy is just 5 times our 8 times, we'll say 10 for gravity. So 5 times 8 is 40, times 10, that's 400 joules for gravitational potential energy. And then kinetic energy is 1/2 the mass, which is 5, times the velocity, which is 10 squared, which is 100. And so 1/2 of that is going to be 250. And so 250 plus 400 is going to give us 650, which is our mechanical energy.